third question that we have, there is another equation of a wave given and we have been asked a different set of questions. The first part is quite simple. We need to find out the wavelength of this equation of a wave, of this wave. Therefore, we see directly go to the coefficient of x. The coefficient of, we compare it to y is equal to a sine omega t minus kx plus phi minus kx plus phi. Therefore, we know that the value of k is equal to 0.2. We know that k is equal to 2 pi by lambda. Therefore, this is equal to 2 pi by lambda. Therefore, lambda comes out to be equal to, lambda is equal to 2 pi upon 0.2, that is equal to 10 pi. So, our answer for the first part is, the value of lambda is 10 pi units. This is 10 pi units. Now, for the second part, we need to find out the maximum velocity of a particle. For finding out the maximum velocity of a particle, we will differentiate this equation partially with respect to t to get the equation of velocity. In that, you no need to write down the full equation, you can see it directly also. The coefficient of t will come outside, and as you already know, for y is equal to a sine omega t minus kx plus phi, when you differentiate it partially with respect to t, this will be a omega cos of omega t minus kx plus phi, due to which the maximum velocity is a omega. Therefore, the maximum velocity of particle can be equal to a into omega, that is amplitude 3 into omega, that is equal to pi, that is equal to 3 pi units. So, the answer for the second part is 3 pi units. Now, for the third part, we need to find out the velocity of particle at x is equal to 0 at t is equal to 2 seconds. So, for that, we directly write the equation of velocity using this equation. This is equal to 3 pi cos of pi t minus 0.2x plus pi by 2. Now, for x is equal to 0, this term will go away and we have t is equal to 2 seconds. For t is equal to 2 seconds, this becomes 2 pi. Therefore, this becomes cos of 2 pi plus pi by 2, that is equal to 0. Therefore, the velocity of particle at x is equal to 0 at t is equal to 2 seconds is 0. For the fourth part, we need to find out phase difference between particles and at x is equal to 0 and x is equal to 2 at t is equal to 1 seconds. For this part, you must know what a phase is. For y is equal to a sine omega t minus kx plus phi, this quantity is known as phase. Omega t minus kx plus phi, this whole thing is called phase. So, the phase difference between two particles at x is equal to and x is equal to 2 seconds can be found out by, for both of them, this term will remain the same. So, the only difference which comes over here. So, the formula, you can check it out also. When you write this down and subtract them, write the phase down and subtract the phase of both of them, you get the difference in phase, that is delta phi is equal to k times delta x, that is equal to 0.2 into delta x. Delta x is the difference in the x coordinates of the two particles, that is equal to 0.2, that is equal to 0.4, that is equal to 4 by 10. So, we get the answer for phase difference as 4 by 10. So, the important thing you should keep in mind is that the particle at x is equal to 0 is ahead of particle at x is equal to 2 by a phase of 4 by 10. So, you just must remember that the phase of x is equal to 0 is greater than the phase of x is equal to 2, as you can check it out over here also. For 2, there will be a term of minus 2k, and for this there will be a term of 0. Therefore, the particle at x is equal to 2 is behind the particle at x is equal to 0 by a phase of 4 by 10. So, thus we get the answer for all the 4 paths.